Whether you're a professional or amateur photographer, there's a camera for every.
Hello to you, my friends. So in this video, you're about to see smart materials. I am here to make a small span of introduction about smart materials. Plants and animals are truly nature's engineers. For example, a simple leaf could harness solar energy more efficiently than our best solar panels. Over millions of years, plants and animals have developed ingenious ways to survive on Earth. As engineers, we can consult nature to improve upon our existing designs and products. By studying nature, we can also gain inspiration for designs that have never before existed.
Smart materials are made in any kind, so I'm here to show you some examples that came from creatures, like insects, animals. So here I'm going to show the butterfly wings, which has a sensor or that recognizes a human-made explosives or bombs.
The blue morpher butterfly is among the largest butterflies in the world, with wings spanning from 5 to 8 inches. Their vivid iridescent blue coloring is a result of the microscopic scales on the backs of their wings. When the morphous butterfly's wings are exposed to various vapors, the light they reflect shifts to different parts of the color spectrum. In biological response, counter-terrorism sensors for detecting bombs and chemicals, each detector, which would be less than half an inch at each side, which specialize in sensing only one particular chemical, an array of different sensors would be used to cover an entire area. As popular science knows about the ultra-tiny sensors, such sensors could be embedded in clothing and designed to color change. They can detect a chemical or biological threat, or they could be a big help to the militaries to identify areas where certain substances, non-rata, might be hiding or lingering.
Butterfly wings, interesting, right? Not only butterfly wings is a special smart material, but also sharks. Have you ever wondered what shark skin are? Shark skins are very massive used in technology. So, take a look.
Sharks may conjure up notions of great and fearsome predators, but one day people may think of sharks are equally as great teachers. Medical technologists to swimsuit designers today are scrutinizing sharks for design ideas. Shark skin is covered by tiny flat V-shaped scales called dermal denticles that are more like teeth than fish scales. These denticles decrease drag and turbulence, allowing the shark to swim faster and more quietly. Olympian swimsuit designers have taken a page from the shark's playbook and created a fabric that mimics the exact proportion of the shark's tentacles, hugely improving a swimmer's speed. Shark bodies are covered in tiny bumpy scales that make it impossible for algae, barnacles, and other marine life to grab hold.
Hi everyone! Today I'm going to show you some 2 top videos about example of smart material. The first video is about eyeball cameras. Cameras have come a long way since Kodak first introduced them in early 90s. All powers come in packet size, but for better close-up, we still need a big zoom lens. Now, the material scientist and mechanical engineer developed a camera that can zoom without typical oversized lens. This camera was inspired by the human eye. Better understanding of this amazing camera, let's watch this.
Whether you're a professional or amateur photographer, there's a camera for everyone. But for close-ups, a big zoom lens helps. Now material scientists and mechanical engineers have developed an experimental camera that can zoom without a big bulky lens. The camera's design is inspired by the human eye,
The eyeball camera uses a thin photodetector layer that senses light and curves in like a crater, mimicking the eye's retina. The dime-sized camera also uses a flexible lens that changes shape to zoom in close for pics. Both the photodetector layer and the flexible lens are stretched out on the surface of the camera. The lens curves outward like a dome, giving the camera its zoom capability. Future uses of the camera include night vision in cell phones and medical imaging. The small, lightweight, inexpensive camera could be the solution to its big, bulky big brother.
Inspiration from nature to solve human problems is the idea behind biomimicry or biomimetics. Over time, evolution has led to some incredible developments, from the photosynthetic machinery in plants to the human eye. Taking a leaf out of nature's book, scientists have developed technologies that seek to mimic some of life's unique innovation. Brick is a biomimetic bricks inspired by Mother Pearl. Chinese chemists have developed a new nacre-like material which is stronger than natural nacre and most other composites. So nacre, which is also known as a mother of pearl, is a naturally occurring composite formed from calcium carbonate and biopolymers that create a brickwork structure. So this is the 7 clever technologies inspired by nature. So the first one is as strong as a spider's silk. Scientists have created a medical product that mimics this property, a flexible tape that can be peeled off a wound without damaging its tissue. The sticky material could be useful for attaching tubes or sensor to the delicate skins of newborns and the second one is a gecko script. It's a new adhesive that's under development, which mimics how gecko feeds thick tube and release from a root. It is made of millions of plastic fibers and gets worth almost a pound of weight, and the materials get even stronger with its use. So the third one is the thirsty Vitas. Researcher from the Massachusetts Institute of Technology had developed a bumpy material made out of glass and plastic that mimics the Vitas pack. The material could be used to collect water or other liquids. The fourth one is the sheen of a butterfly wings. Technologies created the first full-color, video-friendly e-reader prototype based on the way butterfly wings gleam in bright light. The display works by reflecting light instead of transmitting light from behind the screen the way LCD monitors do. So the fifth one is the invention of Velcro. Velcro is commonly used to mean any type of hook and loop fastener. The sticky material was actually inspired by the way plant birds stick to dog hair. And the last one is the snake shark skin. Researchers in Germany had developed a synthetic shark skin made of elastic silicone that reduces biofouling by 67% in tests. The US Navy has funded work to develop similar crater repellent coat.
At dito ay still undiscovered, unexplainable, o kaya naman still under observation. Marami din naman ang kahit isang lumalag ng siyensya o ang tinatawag natin scientific expedition. They'll try to explore the mysteries behind the world. Are you trying to figure out what
hydrogels are polymers of carboxylic acid. The acid groups stick on the main chain of the polymer. When these polymers are put into water, the hydrogen atoms react and come off as positive ions. This leaves negative ions along the length of the polymer chain. When polymer chains are in solution, they tend to coil up. However, the hydrogel now has lots of negative charges, thus is less. Causes the polymer chain to unwind or open up. The next is the attract water molecules. Crystal soil is a non-toxic water-absorbing polymer. When soaked in water, expands up to 200 times its size. Crystal soil is the ideal substitute for water in your flower arrangement. Use hydrated crystal soil instead of water to nourish and help extend the life of your flowers and to grow plants. Crystal soil is ideal for cut flowers, centerpieces, candles, indoor plants, and much more. On the other hand, sheet memory metal is another kind of smart material. And let me define this to you by showing you the magic behind the clip we usually use. Shape memory alloys are metals that remember their original shape. SMAs are used for such things as computers, which are materials that change shape, stiffness, position, natural frequency, and other mechanical characteristics in response to temperature or electromagnetic fields. When SMA is in Martensite form at lower temperatures, the metal can easily be deformed into any shape. When the alloy is heated, it goes through transformation from Martensite to austenite. In the austenite phase, the memory metal remembers the shape it had before it was deformed. From the stress versus temperature graph, we can see that low stress and low temperature Martensite exists. At higher temperature and higher stress, austenite exists.